Okay, we are continuing on our lecture on pandas. I just posted homework 3, and homework 3 covers other stuff and NumPy, and then I'll probably have another homework that will cover pandas as well. But yeah, we're continuing on looking at pandas, and so far with pandas we saw, just kind of how to create data frames, how to use the series, and with the series you can do operations with series, add them together, multiply, divide, things like that, and it matches them up with the index. And so we spent some time working with the index on Monday, and today's lecture I want to kind of show additional operations that we can do with pandas, and these are kind of so I don't know if you guys are familiar with dplyr and the tidyverse in R, but these are similar to some of the operations that you're able to do in the tidyverse in R. So these are things like pivoting your data and also using group by to kind of do summaries and whatnot. Okay. Also, I might include some plotting, and we'll have to talk about matplotlib, matplotlib in the coming days here. Okay. All right. So so here I'm going to create a series of just random values. So I'm doing NumPy random integers. I'm going to get 9 of these things. And I'm creating what's known as a multi-level index, okay, a multi-index. And you can see my index is actually a list of 2 lists, each of those things being length 9, because I'm getting 9 values, and so I'm creating a list that goes AAA, BBB, CCC, and then there's another list that goes 1, 2, 3, 1, 2, 3, 1, 2, 3. So when I do this, this is my data. The values are what? 589, 500, 176. Those are the random integers. And my index is A1, A2, A3, B1, B2, B3, C1, C2, and C3. And pandas kind of just, for the top level index, top level of the index, it just prints out when if it's going to be the same everywhere. It just prints it out here, okay? So if I ask what is the index, we get the multi-index, and we see, oh, you know what? It's actually a bunch of tuples in here. So we have A1, A2, A3, B1, B2, B3, and so on and so forth, okay? So with that, with a multi-level index, you can select values via the top level index, okay? So if I do locate on B, basically it's going to pull out the 500, and it just kind of gives me this little subset. And so there's this thing, what it returns is actually a series with index 1, 2, 3 here. If you want to select via the inner index, you can do .loc, and you say kind of like I want all on the top level, and I only want the second level where it's equal to 2, okay? And so we can see we get basically A2, B2, which is 0, and C2, which is 7. So we get those values. And now the index on this thing only keeps the top level, the A, B, and the C, and everything, where the inner index, the second level index, is equal to 2, it does that, okay? So this indeed it's just a panda series. All of these things after using .loc is a series. And if I ask what is the index on this, it's just a regular old index, ABC. Okay, ABC. I think that makes sense as far as how a multi-level index works, and you're not limited to just 2 levels. You can unstack the data, okay? So here, this is what we would say it's in stacked form. And if you unstack it, okay, it's going to take the second level index and it's going to basically pivot your data into columns. You're going to have a column for 1, 2, and 3. Okay, so now we have our index is now A, B, and C, and the kind of that inner column got unstacked into basically the column index, right? So we've taken the 5, 8, 9, and now we've basically pivoted this set of 3 into a 3 columns here. So if you ask what is the index on this thing after unstacking, it's not a multi-index, it's just a plain old index with values A, B, and C. And what is the shape? The shape is going to be 3 by 3. So whereas prior to this, it was just a series. So we didn't have that. Okay. Unstack has an inverse operation called stack. So if I take this, I can call stack, and it's going to create a multi-index out of this. All right, we're going to get basically back what we started off with. But you say you have unstack and you have stack. So unstack produced this, and if we call stack on something that looks like this, you're going to get back this. So it just takes the different columns and it stacks them up. Okay. If this is what we have, you can also take your multi-index and you can do a swap level. And so swap level preserves the order of the data, and now instead of going A1, A2, A3, and B1, B2, B3, now you have 1A, 2A, 3A, 1B, 2B, 3B, and 1C, 2C, 3C. All right, and so now we see this is how that works. Okay, and on this swapped data, the location accessors work as we would expect. So if I say locate second level A, we're going to get this 5, 8, 9, and the index is 1, 2, 3. If you use swap level and you want to sort based on kind of the new multi-index, so we get all 1s and then all 2s and then all 3s, you can call sort index. So you sort it on the index, and you're going to get this. Yeah.
What happens if you swap level on something that has more than just 2? Like a multi-index with 2 layers.
That's a good question. Let me see. You know what? Now I'm afraid I said something wrong. I think it just cycles through them, but let's so I've got A, B, C, 1, 2, 3. We're gonna have, okay, so we'll just do 4, 4, 5, 5, 6, 6, 7, 7, 7. Okay, I don't know. I'm not sure what's gonna happen here. We'll call this data 2. So we have this and data.index. So we have this 3-level multi-index. Okay, so right now it looks like this. And let's do data2.index. Looks like this. And let's do data2.swapLevel. So it looks like it takes the innermost, so the 4, 5, whatever, and it swaps those two. Here, let's see what, click on a function, series. So let's see. Series was level swapped. IJ, levels of the indices to be swapped. Okay. So you might be able to swap, say, index 0 and index 2. Okay. All right, so you, if you have multiple indexes, or multi-level, you can specify which indexes to swap. And I guess by default, it's going to take your last two. So if it goes 0, 1, 2, it'll take 1 and 2. So, so here we're swapping 1 and 2, but you can swap levels 1 and 0, or level 0 and 2, or something like that. So that's how swap level works. Okay, good. I didn't kind of thought of that, so it's a good question there. I'm gonna take those out though. All right, I'll go ahead and just remove that. So swap level, yeah. So here I've just been swapping level because if you only have two levels in the index, 0 and 1, then it makes sense with how they're going to get swapped. But yeah, if you have a multi-index with more than 2 levels, you can specify which ones will get swapped. Okay, all right, so here's our data once again. I can swap level here and unstack. So, so if I swap the level, now 1, 2, 3 goes on the outside, and then unstacking that, ABC becomes the column, right? So so here's our original data, ABC 1, 2, 3, 1, 2, 3, and then when I swap the levels, 1, 2, 3 will be on the outside, ABCs will be on the inside, and then we unstack that, we'll get that, okay? And again, compare that to data.unstack, the top level index becomes the rows, and then the inner index becomes the columns. So these are basically transposes of each other, but it also kind of makes sense the operations in which we, the order in which we conducted these operations, right? So after swapping the level, then the 1, 2, 3 becomes the outer index. If you have a series with a multi-index, you can call data.sum, and it will just add the whole series together. You can say you want to group by a certain level of the index. So group by level 0, it will group by the A, B, and C, and you'll get a sum for A, a sum for B, and a sum for C. So again, looking at our data, the sum for A, 5, 8, and 9, add up to 22. Okay. You can also say group by level 1, and it will group the ones together. So 1 is 5, 5, and 1. And you'll get 11, 15, and 15, so on and so forth. Okay, so that's how a multi-index works. And if you understand how the multi-index works, then we'll be able to kind of do these pivot operations and reshape our data, because basically they're all kind of powered by the this multi-index. Let me go ahead and give you your first view quiz answer for today, which is the letter B. B as in bear, B. Okay, so here is some data that I'm making up. It's just the integers 0, 1, 2, 3, 4, 5. But we have it in a data frame where the rows are named alpha and beta, and the columns are 1, 2, and 3. The words 1, 2, and 3. Okay, so so as far as the index, I gave the index names. I go name equals letter, and then the columns name is equal to number. So I mean, it could just be like, you know, the name is the row and the column is variables or something like that, right? Okay, you can call stack on this. What do you think is going to be the result of calling stack? How many rows will I end up having? 6, okay? And we'll basically stack these columns 1, 2, 3, and we'll have alpha 1, alpha 2, alpha 3, and then beta 1, beta 2, beta 3, right? And so we get this series where we have 6 values there. Okay, and then, you know, stack and unstack are inverse operations. So even though I called stack here, if I call unstack on this thing, we get back what we started off with. Okay. And here we also see when we stack them, it preserves the kind of the names that we assigned to the index and the columns. When you unstack, you can unstack which level. So by default, unstack will unstack the innermost index. But here I can say unstack the level 0 index. And this, I think, does exactly what we expect. If we unstack the 0 level index, we're going to get a row for 1, 2, 3, and then column for alpha and a column for beta, which is exactly what we get. Okay, and if the indexes are named, you can say unstack based on the letter, or unstack based on number, or whatever, basically whatever names you gave to the levels of your index. Right, so you can, I don't know what would be an example where you have a multi-level index, you know, something, I don't know, you know, tier 1 and tier 2 or something. Okay, when you do, if you create your data, you know, unstacking could end up creating some missing data here. Okay, so here I have series 1, and we have the value 0, 1, 2, 3, and its index is A, B, C, D. Here's series 2, and I have the values 4, 5, 6, and it comes with index C, D, E. And I could just kind of concatenate these together, but here I'm going to concatenate them, and I provided the argument keys. And if I provide the argument keys, then I will get a multi-level index. Okay, and so it adds basically a level to the index. Key 1 is associated with series 1, and then key 2 is associated with series 2, and so I get 1 A, B, C, D, and 2 C, D, E. Okay, so if you see this as your data and you call unstack on it, what are we going to end up getting? How many columns? How many rows? Yeah. Well, just the opposite. We'll have 2 rows but 5 columns. Okay. So we unstack the innermost index, which has 5 unique values, A, B, C, D, E, and those become the columns, and then the rows, we have the outer index will be 1 and 2, okay? And because we don't have a 1E, it introduces a missing value, and we don't have a 2A or B, and those get missing values. If you have something that looks like this and you call stack, it basically drops those missing values. But you can also say don't drop the missing values. You can say drop NA equals false, and it preserves them. Okay, so let's take that knowledge and try a small data wrangling example. So this is some generated data set, or I don't know, compiled. All data are from the Federal Reserve Bank of St. Louis, except for the unemployment rate, which was taken from the National Bureau of Labor Statistics. Okay, so this is some macroeconomic data for the U.S. from 1959 to 2009, and we're looking at real GDP, real consumption, real, I don't know, whatever all of this stuff is. I don't know enough about economics to really comment on any of this stuff here. Okay, but I've read that in, so you can kind of take a look at what the data looks like. So it reads it in, and we get all these things. And we can also just ask for data.info. And data.info basically gives you a little kind of summary of the structure of your data. So here it says there's 203 entries in your range index from 0 to 202, and then your columns, go from 0 through 13, 14 columns, and these are the different column names. We have 203 non-null values, so really no missing values at all, which is impressive, and everything is a float. And so this is kind of the head of our data, and that's what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so all 14 columns happen to fit on our screen. Great. So one thing we can do is we can take, right now we just have index 0, index 1, index 2, index 3 up through 203, which, maybe we don't want, okay? So what we can do is we can create a period index, so kind of like a date index, but this is based off of different kind of periods, and so you can read more on this on the period index. And I don't know, there's all kinds of examples for how you'd want to do this. But if you have something like quarter 1 and quarter 2 and things like that, you can take, you can specify. Period index allows for years and quarters and months and weeks and things like that. So here I'm going to specify we've got the year in this column and the quarter in this column. And what we want to do is we want to kind of turn them into dates. Okay. So if you look at the periods here, we have 1959 Q1, 1959 Q2, and it goes all the way up to 2009 Q3. Okay, so we will create a new index called with the column names that we want. The column names that we want, we'll just look at real GDP, inflation, and unemployment. Okay, so these are the column names that we want. All right, so these are going to be the things. And then using that, I'm going to re-index our data. So basically, I'm just going to select the columns using this index, new index that I've specified. So we're going to take data, and we do data.reindex columns equals the columns. So this forces the columns of the original data to match the columns that I specified here. And so if I do that, so now I just have these things: real GDP, inflation, unemployment, and so on and so forth. We're going to take our period index, which is currently 1959 Q1 and so forth, and I'm going to convert it to a date. So there is this method. The period index has additional methods, and again, everything you can kind of look up. So these are the attributes, and then so the methods, one of the methods is convert it to a timestamp, and you can specify how you want it done. And so we're going to convert that periods into a timestamp, and so we'll look at, so 1959 Q1 will be 1959 January 1, 1959 Q2 becomes 1959 April 1st, and so on and so forth. Okay, so it converts basically these periods into dates. And here we're going to say start, and I think you can also specify end. And so instead of January 1, it becomes March 31st, 1159. And then the end of Q2 is June 30th, 1159. Okay, but here we'll go ahead and do start. So we have that. And okay, currently the index is just 0 to 23. So all I'm going to do is I'm just going to overwrite the old index. The old index used to be range index. So I'm going to just take data.index And this thing that I did to timestamp, this date time index, I'm going to just replace it. Okay, so I'm not re-indexing or altering the existing index. I'm just taking this new thing that's an index and I'm just replacing the old one. Okay, so if I was not careful and I had like done some sorting operations and these are no longer in the original order that they appeared in the data, and I put this index on top of it, then we would get a mismatch between the data. So if you're going to replace an index, you kind of have to make sure that your index that you're replacing it with is in the correct order that the data is currently in. Okay, so once I do that, now my index, so now the data, which was like this, 2710, 0, 5.8, 2778, 2.34, 5.1, those values are still the same, and it's just we now have dates rather than 0, 1, 2, 3. Okay, we can take that and we can stack it, and if we stack that, we get one giant series with a whole bunch of values, and all of these things are in here. And I can take this stack. You can call something called reset index. Okay, so right now my index is the date and the item. Reset index will take your multi-index and turn them into columns. Okay, and then it's just going to attach on a range index over here. So here I stacked the data, and now into a big series, and then you can call reset index after you've stacked it, and it basically takes the kind of the different levels of your index and will turn them into columns. This one didn't have a name, so it's just 0. We should probably call it 0 value, and we can say 1959.01 item is the value, real GDP value is 2710, 1959 inflation, the value is 0, so on and so forth. So, this index is just a range index going from 0 to 609. That kind of makes sense. And we can call, here I'm going to save this resulting thing, and we're going to call it long data, L data, for long data. And to rename this column, which is currently named 0, I give it a little dictionary. I'm going to say rename 0 with value. And you can rename multiple columns with a dictionary with kind of multiple entries here. Okay? So far, okay? Does this kind of make sense? What I'm doing? And if I tried to call unstack on this, it's not going to work, because unstack requires a multi-index, and there's no multi-index here. Okay, it's just yeah, it just kind of gets confused here. Okay, so yeah, unstacking doesn't work for the long data. You need a multi-index. Something like this you could unstack, but not this. Okay, so if you have data in long form, you can go back and turn it into wide form using this argument called pivot. Okay, so pivot, we say, all right, take the date, the item, and the value. We're going to pivot those things. Okay, and so again, pivot is kind of like doing an unstack operation, but we don't have a multi-index, right? So here we don't have a multi-index, so I can't just call unstack, but I can take my data. If your data comes in long form, you can then pivot. You can say, all right, basically your new row index will be the date. Your new, the items, the values in items will become the new column, and then the values come from the column value. So we've basically unstacked our data. We've unstacked our data despite not having a multi-index. So this has all been kind of like one long circular path here, right? So we've seen like when you have the multi-index, it's very easy to stack and unstack, right? You can create a multi-index by stacking things. If you have a multi-index, you can unstack it. But sometimes you read in data and it comes in this form. And what if you wanted to unstack this? Okay, you can't just call unstack, but you can call pivot, right? And so pivot basically establishes something that kind of looks like a multi-index, right? The formal here I just wrote date, item, and value. The kind of the formal arguments are index, columns, and values, and those correspond to exactly what we've done, right? All right, I'm sorry. Here I've swapped them. Okay, if I say the index is here, the index is the date that becomes the new index. Here I can specify the other way. I could say I want the items to be the new index, and that will be the row names, and then I want the columns to be the dates, and then now I have like 203 dates over here, starting at 1959 January 1, going, and then it skips a few columns, and it shows us the end. The last one would be 2009 July 1, and so on and so forth. We have that. Okay. Our data, all of this leaves our data unchanged. So none of these methods actually affect the data, even if but here I have the long data right here. Okay, let me just do a couple more operations here. Let me give you your second view quiz answer. Is D as in dog. D as in dog is our second view quiz answer. Okay, so here is another data set. Here there is no multi-index here, right? It's just a regular old range index, 0, 1, 2, 3, 4. But I have a few variables. I have variable key 1, variable key 2, variable data 1, variable data 2. Okay, so you could just imagine these being like categorical variables and numeric variables and so on and so forth. Okay, so even though you don't have a multi-index, right? So when you have a multi-index back here, we were able to call something like sum on level, where did it go? Group by level this and call sum or something like that. You can still group by a particular column in your data. Okay, so here I'm going to take my data and I'm going to group by key 1, and I have two values, I've got A's and B's, and the values are A, B, B, and A. And here it says, okay, well now you have a group by series. So once you have your grouped thing, you can call some kind of summary function like mean or sum or whatever. And so we can say, okay, for key 1, on data 1, okay, what is the mean of A? 5, 11, and 9. 5, 11, and 9, the mean of those things is 8.33. And here, we're looking at, DF data 1, this column, what is the mean for group B? 12 and 8 gives me a mean of 10. Okay, if you don't specify the column, so over here I said DF data 1, if I just call it on the entire data frame, and if I just say data frame group by data frame key 1, so take data frame, group it by key 1, and ask for the mean, then we'll get, it'll do it for all the numeric, it'll give you the mean for all the numeric values that it can calculate the mean for. So it ignores key 2. Key 2 is categorical, so it's not going to try to calculate the mean, but it says, okay, group A, here's the mean for data 1, and the group B mean for data 1, data 1. Here's the mean for data 2, and so on and so forth. Okay, so you can just call that. You can group by multiple things. So I could say group by, and here I give it a list or a tuple of column names. So we're going to say group by key 1 and df key 2. Okay, so here I'm specifying just data 1, 5, 11, 12, 8, and 9, and we're going to group by key 1 and key 2, and so this creates a multi-index. Okay, so for a lot of these things, here actually, let me just show you the data frame here. So we have A1 is 5 and A1 is 9 here. So the only thing that really calculated a mean is A1 because we have a 5 and a 9, and so the mean there is 7. But then there's actually only one entry for A2, there's only one entry for B1, and there's only one entry for B2. So those are just, the means of those are just the values that show up in the table. Okay, but yeah, if you call group by and you give it multiple variable names, you know, assuming these are all categorical, it'll create a multi-index for you. And then with this, once you have a multi-index, then you can use operations like stack and unstack and get all of these things out. Okay, so the multi-index is a very handy thing, and group by allows you to kind of create it, and then, you know, pivot basically implicitly creates a multi-index, but then gives you the final result at the end there. Okay, here is, I'm just creating separate arrays. Okay, so this one, I'm creating an array Ohio, California, California, Ohio, Ohio, and then here's another array that says 2005, 2005, 2006, 2005, 2006. So you can perform group bys on like series or unrelated variables. Oh, I shouldn't say unrelated. You know, as long as these things are kind of like in the same order, and you kind of, it's like it's as if you concatenated or added that column, and then you're going to group by that column. So even though they're not technically part of the data frame, you can take data frame, say column data 1, and you can group by, you know, these additional arrays that just kind of exist separately. So if I do this, you know, California 2005, I guess is this entry and that entry. It's really only just the second value, so we get a mean of 11. California 2006, there's only one entry there, and that's going to be the 12. I guess Ohio 2005, it will be entries 1 and 4, or I guess index 0 and index 3. So 5 and 8 give me 6.5, and the last one is just entering the last entry, 9. So you have that. And then finally, you don't have to use mean. You can use any other kind of function. So size will just tell you, you know, how many values do you have. You know, there's what do you have? You have min. You have I don't know. I'm drawing a blank here, but you know, lots of kind of summary functions that are available that you have there. Okay. Once you create a group, okay, once you create groups, you can actually like iterate over them, right? So here, these are just two very silly loops, for loops that I've created, and so here I'm going to create key 1, and you're going to get basically this tuple that can be unpacked, and the name will be key A and B, and then the group will actually be like a little data frame. Okay, so here I'm going to say for each kind of item after group by, we're going to get two groups, a group for name A and a group for name B, and I'm going to just print out the name, and I'm going to print out the group. Okay, so name is A, and then here I drew some dashes in the group, and then if you ask what is the group is basically a little data frame here. Okay, it's just a data frame where key 1 is A, and then we can say, all right, print out these additional things, you know, what is the mean? What's the mean of data 1 means and data 2's mean and things like that. Okay, so I can do that. And then once it's done, print out, you know, a bunch of stars, and then do the next thing. Name B, here's the group, here's the mean, and stuff like that. Okay, so when you create a group by, you're basically creating like little tuples where one of the objects is like the data frame filtered down to those entries. Okay, same thing over here. Group by key 2, so we get name is 1 and name is 2, and then we get basically the data frame where it's filtered down to key 2 is equal to 1 and key 2 is equal to 2, and so on and so forth. And we induce, you know, what is the mean of each of these things or whatever. And so you could imagine doing some kind of operations over each of these, you know, subsetted data frames to work through. Okay, so very handy as far as doing any kind of data analysis with pandas. Is a lot of times you want to kind of subset and you want to kind of split up your data into different groups based on these grouping criteria, and you want to do different operations. And you'll notice a lot of these things, you just kind of chain the dot notation, right? So a lot of these things, I just said df, take this, and here I wrote here I have df square bracket, but I could have also like I could you know, one of the attributes, you could use dot notation to just kind of pull out the attribute there. So, you know, these two things are equivalent, and so there's a lot of times as you're reading, like someone else's pandas code or something, you'll just see like all these dots and they're all just kind of chained and things like that, and that's very, I would say, typical of like how maybe we do like data wrangling and data science when we're using Python, is we just keep chaining all of these dots together. We just say like, oh, data frame dot this and dot that, and basically all of the attributes show up with dots, and all of the methods are also dots. So the column names are basically attributes, and so you can say take data frame, work with column data 1 on, use the method group by. How are you going to group it? You know, use column key 2 and column key 1 and key 2, and then what I want you to do is I want you to find the mean and things like that. Okay, so you're gonna just see a bunch of kind of dots chained together. We'll cover object-oriented programming a little bit later in the course, and you'll kind of, maybe it will help you understand how all of these dots and things work together, because this is kind of a product of Python's object-oriented philosophy on methods and attributes and all of that. Okay, how many view quiz answers did I give you? 2? Okay, the last one is A. A as in apple. A as in apple is your last view quiz answer for today. Okay, that's all I have for today, so we'll go ahead and leave it at that. I have posted a homework assignment on Canvas, and then I'll probably post another one pretty soon that will use pandas. Okay, with that, we'll see you guys on Friday.